Hello, everybody. Welcome to Speakeasy JS, the meetup for mad science, hacking, and experiments. I'm Faraz, and I'll be your host this morning. Mad science is all about building things that make people say, I didn't know that was possible. And today we have a really special event for you. We're joined by a whole bunch of people. So I'll introduce them one at a time. We have Mikola.
Hello.
We have Timing.
Hello.
Jinjin.
Hello, everyone.
And Yo-Yo.
Hello.
Hello. It's awesome that you guys are all here. Super happy to have you. And it's going to be an awesome talk. We're talking all about Box3, the game you guys have been working on at CodeMao, and I guess it's called Dai Ma Dao in Chinese. And yeah, you guys are going to tell us all about it, right?
Yep. Yeah. So I can get into the presentation right now. So is my screen on?
Yep.
Okay. So, all right. Hello, everyone. I'm going to talk about this crazy project, which I started maybe 4 years ago and is now sort of wrapped up, or at least my involvement with it is done. And this is, of course, a joint effort. So I brought a couple of the people here who I feel, definitely contributed a lot to making this thing what it is today. And yeah, so let's just get into it. So first of all, what is this Box3 product, right? Or what is Box3? So the idea behind this is it's kind of like, Minecraft and Roblox, but in a web browser. So it's similar type of style, platform to Roblox. It's all user-generated content. It's real-time multiplayer with 200 plus player rooms. There's in-browser content creation tools for making games and writing scripts and stuff. There's no installation, no app store, whatever. You just click a link and you can play it. It's all written from scratch. So everything from the game engine to the networking stack. And there's actually very few dependencies in the project. And it runs even on really cheap smartphones and hardware from years and years ago. So this is our mascot down here, GG Meow, and this is sort of like a little video of the game in action here. And if you want to try out the game yourself, here's a little link you can go to. So you can go to box3.fun/p/cyberwar, and you can try playing one of these games right now with other kids and stuff in your browser. And there may not be too many people online because it's 1 a.m. And in China. And so I also thank Yo-Yo and Timing and Jinjin for coming up and waking up at this awful hour to come do this presentation for us. But yeah, and it also should work on a mobile browser too. So you can play this on your smartphone or a tablet or whatever, and everything should just work out of the box with no struggle or difficulty there. So what's actually inside this thing? So what are like the main components of Box3? So there's sort of a core game engine. There's a multiplayer game editor, which lets you make games. There's a Voxel creator thing similar to like Magic of Voxel. There's a music editor, kind of like a very basic sort of Ableton-like tracker editor thing. There's a giant web portal with a lot of things going on in it and a lot of social features. There's a moderation system, and then there's a bunch of like REST APIs that sort of glue all these things together with different plumbing. So I don't know, Timing, if you want to talk about this, that's okay. Although I know his English is maybe not the sharpest, right? But these are sort of like the high level, view, like with boxes and stuff of where things are, right? So you have the website platform, you can log into it, you can make, or you can play games. The games can be created using this editor, which get published. All the user content goes into IPFS and pulls from it. Then we have all these other content creation tools, some of which are public and some are sort of internal things that we use for creating stuff. And that's kind of the high level thing. So Timing, would you like to talk about the game server deployment or say a few words about that?
Yeah.
Okay.
So the aggregate requires at least 2 game servers, one for play and one for edit. And it is not cheap to run these servers. So we need to stop them when they are idle. So there is a problem how to start the server in time when you need it again. So the first step is browser will request to the backend to start the game server, and the backend will connect to the Kubernetes cluster to create a game server container and get the IP address and port and then return to browser. So browser can use the address to connect to the game server. It's not too hard.
Yeah, at a high level, this sounds very simple, but let me tell you, there are a lot of really gory details to make this work that Timing sorted out here. So there's a lot of things that you have to do with pinning ports and addresses and also working with persistent storage. So putting this together was a non-trivial thing, but Timing did most of the stuff. So if you have questions about that, you can feel free to ask them maybe afterward. Also, we have an editor component here for creating models, which was created from scratch by Jinjin. So he built this whole thing in himself, and he can maybe say a few words about it right now. So Jinjin.
Hi everyone. This is the first product I built for the Box3 is called the Voxel Editor, and it basically use mixed greedy mesh algorithm, but Mix told me that we could just modify the algorithm to remove the T-junction to make the model looks better in the games. And also, I use a multiple web worker to boost the performance because when you're trying to edit a very large voxel model in real time, if you put all the calculation in main thread, it will just crash the browsers. And for doing that, I also have to set up a API for synchronize all the user operation to web workers. And to the end, we Mix and I create a compact customized mesh format which is built on top of the MMO schema and could reduce the size, reduce a bunch of size for the assets in the games. And I also add a real-time path tracing rendering mode, and recently I have added a mesh voxelization features to this product. And here's what it looks like. And the first picture is the basics user interface, and you have basically all the tools that you need to editing for voxels. And on the left, showing internal templates models. These models are actually generated by the sign distance function. So it basically is just some function which requires no preset. And on the left is the real-time path tracing mode. And on the right is the voxelize feature in these voxel editors. And the second product is music editor, but it's actually the first product that I have been trying to create since 2017. And I think everyone who uses web audio APIs will understand that these APIs is actually difficult to use. And for doing that, I use Tone.js on the buttons, but I have made some customized because I think that the latest version of Tone.js have some capability issues with iOS browsers or the Safaris. And in these projects, I create a set of unified time and pixel unit conversion because when you are trying to edit audio tracks or MIDI tracks, there have a bunch of units convert between the seconds or the pixels or the pulse. And also there includes a full generated MIDI synthesizers, which means all the audios that create from the MIDI are actually generated by web audio APIs, and you don't need to download any audio resource for this instrument. Yes, and it also have a virtual piano keyboard, which you can record when you play it, or you could record from the microphones. And yes, that's it. And the image show that you can create clips or the channels, or you could edit the MIDI clips, and you could edit, do some simple audio editing. And when you publish, it will generate a MP3 file, which will upload to the IPFS. Then you could download the file from the game editors. So on the left is showing how you import model into the game editor. You could just open the panel and click and drag it. Then you can manipulate these models with UI 3Ds. And on the left is showing that you just downloading the BGM. But of course, there's like a dozen things that you could apply the audio effects to it.
Yeah. Also, do you want to say any words about the UI 3D stuff? This was actually a cool idea. It's like basically we have a React wrapper that allows you to make these 3D UI elements, just using like a virtual DOM interface. Yeah.
Okay. Oh yes, yeah.
Which Jinjin created.
Okay. Oh, it's a Mikola's idea actually. I just the person that implement all this stuff.
Yeah.
It utilized the React context, which the context have a state, which can also be used to put into the WebGL renderings. And when you create a new React component, or then in that create function, it will also generate the data for 3D rendering. And that's basically the idea how you bind 3D data with React.
Yeah, and then I think I can say a little bit about sort of the scripting and game code editor. So another critical component is all these games that these kids make on Box3 have some software that they write to run the game. And these are all created using a JavaScript-based coding environment. So there's like a text editor, which is a collaborative multiplayer thing. So you can have many people here in a game editing this at the same time. All of the code runs in a JavaScript sandbox created using isolated VM. And then the messages from isolated VM are serialized and sent back to like a main thread for the game server. So it's possible for scripts to have like infinite loops or whatever, or blow up their memory without crashing like the main game server. And this is relatively fast. There's also like an interactive shell for debugging and other features for like running these things on the server. And we use Visual Studio Code like Monaco to basically, or Monaco from Visual Studio Code to do all the rendering and type checking in the browser when it renders the code editor. So yeah, I think this is also a good point to segue now into the engine technical details. And there's a lot of crazy stuff here, and I'm not going to go into like every single thing. But at a high level, the game engine is all written in TypeScript. And we only use WebGL 1.0 APIs and ES5 compatible features. We use Regal for like rendering and doing all of the graphics stuff. The networking and physics and everything is all basically like custom stuff. There's like an in-app debugger that we can use to run and simulate the game server and the client in parallel, which makes it really easy to like you sort of step through and debug like networking glitches. And we have like graphs for tracing different variables. You can inspect all of the game state on there. There's like a whole bunch of like crazy random stuff in the development environment for this that we're just going to skip that for now. And in terms of like rendering technology, there's a few interesting tricks around basically working with voxels. I mean, again, we use greedy meshing, which at this point is a pretty standard idea. We have some level of detail stuff that we do for rendering the voxels. We also use the advanced cave culling technique, which was pioneered by Minecraft for visibility culling. We have like a lot of fun little features like animated voxel textures, particles, and sound effects for different objects in the game. Lighting uses a very simple material system like the standard Unreal model of basically roughness, metalness, albedo, and emissive. We have high dynamic range lighting with dynamic exposure calculated based on the camera position, that's a trick to get that working. Let me tell you that, right? It's not using any kind of screen space post-processing, and it runs just purely on the client, in mobile, right? For bump maps on voxel textures, we have basically like a 64 by 64 bump image. which we can use for displacement mapping, normal maps, and pre-computed ambient occlusion per voxel. We also have Minecraft style like flood fill lighting, but we have basically 32-bit instead of 16-bit. So instead of like Minecraft, where it's basically just torches plus skylight, we have RGB plus sky, basically. So you can have colored lights that you can place in the game. And then for direct lighting, we use cascaded shadow maps, which are optional on low-end devices. And then we have like a bunch of fake little post-processing effects for volumetric lighting, depth of field or like bokeh, like lens distortion, and bloom effects. And then there's a lot of crazy stuff around like the voxel compression, and that's about it, right? And yeah, all of this is written in Regal using GLSLify for managing shader modules. So that's that. And then before going too much into the rest of the engine, I want to say a few words about MooDB, which is sort of the like one-stop shop that we use for all of the networking stuff that goes on in Box3. So MooDB is unfortunately not that well documented on GitHub, but it's basically like a collection of little submodules. The core one is this set of tools for creating schemas in TypeScript, which we can then use to do like zero copy diff and patch algorithms for saving data into like a stream. We also get memory pooling for schema-based objects, so we don't have like a bunch of garbage collection going off all the time. And it also gives us some runtime reflection over types, right? So we have both like the type data and then the schema data, which we can use to do different things, like for generating APIs to bind like the scripts to the game thread. We can use the reflection from the schema type info. And because they're schemas, this is much faster than using JSON.stringify or whatever, and they can all serialize things into a sort of small binary format rather than using JSON. We also, on top of this, have a networking stack. So we have a socket wrapper that also does like UDP and TCP emulation. And we have a like sort of fast, low latency message passing system called MooDB, which is like the core of MooDB. And this just allows you to like write modular protocols for connecting different client server apps. So like a typical MooDB thing just writes a protocol, and then you give it like a list of the messages that you accept, and then the client, you know, implements the set of messages they accept, and then you basically, like TypeScript will automatically ensure that everything connects together and it all works, right? With like the minimal amount of boilerplate to validate it compared to like a JSON or like REST-based serialization system. And also we have this cool thing called Murda, which is basically how we do all of the collaborative document editing. So I'll say a little bit about that next. And then we have this MooRPC, which is basically like MooDB, but instead of for WebSockets, it's for like REST API. So MooDB would be for like small like session-based protocols where you connect to a server, and then the server handles those sessions. The RPC stuff doesn't have like a session handling component. It's more just like call an API on a server. And we use that basically for like project-wide RPC stuff. I'll come back to that later. But first, like I just want to say, like again, there's a lot more I could talk about with this thing here too. But Murda is basically like a sort of replica document synchronization framework. It's sort of like a schema-based approach to this, right? So the idea is that you create a schema using Murda, which describes your document, and then the schema will actually give you a set of axioms that can be applied. And the key thing is that there's a really simple synchronization algorithm which can be implemented from this, as long as all of your actions that you can apply obey this little axiom down here, this sort of move the front rule, right? And we can actually ensure that this is true for every action that we construct through this RDA thing. But again, I don't want to go into the details of this. This is probably a whole other talk. It's sort of, you get a synchronization algorithm, which is a little simpler than a CRDT and allows you to make things that are faster than CRDTs. So you get performance similar to operational transforms, but with no term rewriting. And you don't have to do all of the other kind of bullshit with like differential synchronization, keeping many replicas around. So that's the high level idea. So yeah, if I just, let me go back to this other slide here first before getting into the other thing. So like, I just want to sort of summarize what the pros are of this. It's basically, you have a protocol which is even simpler than the CRDT replication protocol. You have performance, which is as good as operational transforms or differential synchronization. And the protocol doesn't involve all of like the crazy stuff of differential synchronization. So that's the upside of that. So now I want to start moving into like the rendering technology and make sure I don't like use up all the time here. So one like kind of neat trick is we do have like a fully dynamic voxel level of detail method, which I've described on my blog, right? But we can do geometric level of detail on voxels based on like camera distance or whatever. And this is like a continuous level of detail method. So you can get like, coarser or finer voxels depending on where you are. And it, it's the level of detail pops in based on view distance. Let's see. Yeah, and then I probably should throw in a slide to talk about advanced cave calling, but I can get to that. We can just skip that part too. For physics, right? The physics engine in this game had some pretty strict requirements. So first, it has to run in a browser on a crappy phone. It has to be really, really stable and support extremely variable time steps and also be deterministic, which sounds crazy, almost impossible to do. But we did manage to pull it off. It has to be very fast. So we want like a sub-millisecond solve time. And it's got to be very simple because I don't want to be running around doing maintenance on the physics engine while trying to ship other features and do other things. So with a normal physics engine, I would be skeptical that we could pull it off like completely. But basically, since we sort of looked at games like Minecraft as the reference or implementation, or the reference for what we were trying to build with DaimaDAO or Box3, we decided to go with a really basic platformer style physics engine. So we ended up just using only translational rigid body dynamics. So these would be like platformer type physics, not full rigid body like motion with rotations and stuff. And our solver, it supports contact constraints, adhesion and motors, and just infinite stacking. So you can stack as many objects as you want with total stability, right? Like nothing will ever fall over or tip. And because we're using translational degrees of freedom, which commute, it's possible to solve these things much more efficiently using just direct elimination rather than an iterative like impulse-based solver. So we don't even use an impulse solver. It's all just like a direct like elimination solver that handles all contact constraints. It's very similar in spirit to the method by Gundelman for like non-convex rigid objects with stacking, but this works for not just like the one special case of stacking objects under gravity on the ground, but it can even handle like pushing something into a wall or whatever, right? So, or even like a sliding stack of bodies. The collision detection uses 3D greedy meshing, and we have swept volume support. So another quick word about the collision detection. So this is a project Timing created. So Timing built this module, Arbush 3D, to realize some of these things. And this is basically how we handle dynamic collision detection for objects. And we can bake and pre-calculate these things ahead of time. And then this does sort of all of the bulk insert, remove, and search and collision detection under the hood for all the objects in there. So this is sort of like a 3D version of an R tree, basically. That's it, how we do the collisions, or just a 3D bounding volume hierarchy. So, okay, and then now trying to move a little bit into some more back-end stuff. So I don't know, Timing, do you want to talk about some of these things, or would you like me to say this slide here?
Oh, I think you can talk about it.
Right. So all of the data for the game is stored in IPFS, right? So we wanted to basically have immutable, authenticated data, and this is a typo up here. And we basically have all of the user content, which goes into IPFS, but also all of like our web assets and all of the optimized and compressed assets that we generate from the user data. So there's a bunch of challenges to working with this, like how do you migrate like an immutable chunk of data that's in there? How do you handle optimizing? How do you audit this and index it? And again, there's a lot to talk about here, but I'll just do this at a very high level. We have sort of like a system where we can just run tasks lazily based on data that we pull out of this thing. And there's a few general patterns. So one of them is to handle migrations. We sort of always do this migrate on read. So whenever you read something, you have to run the migration for it. And you have to just make sure that those migrations like are somewhat self-contained, so they don't ever like change. And And so we have sort of like two layers for the data, right? One is like our canonical data of record that we store in like just stable stringified JSON blobs. And then we have other data which we send out to users, which is all binary compressed. So the internal system basically reads and writes, reads these JSON blobs, and it will write out the binary data. And then the users only pull this binary data from the underlying content storage. So that's basically it. And then we just sort of lazily compute everything. Also, for some of the content delivery stuff, we just keep the same IPFS multi-hash format, but we basically switched the multi-hash to sort of work on a different content delivery network. So we're just using the IPFS block store. So we just have those block stores go to like a separate CDN, and then those can just lazily fetch the stuff out of the IPFS pool that all the server stuff works on. So that's it. And I guess, Yo-Yo, would you like to talk about the character animation here?
Okay, so we have designed this character animation. We have the custom inverse dynamic chain and solver, and we use the keyframes that is made by BVH. So we have to use to make the clients load the website as soon as possible. So which means we may have to minimize the loading data when they are first coming into the game. So we use as a list of the keyframes here. We just generate those animations and insert them into the frames and make them look smoothness. And now we have already support animations that includes walk, run, fly, rise and land, jump, double jump, and and a lot of the animations here. And we have another internal design tools. It's rig editor. The rig editor here, it can help to configure the skeleton and export the palette that can be imported to the game engine. So with this one, you can just adjust like the hand and the body, and you can even make they have very long hands and arms to make a special people. And you can also adjust the animation here and to see how it works really in the game engine. And you can also bind the skins for this character, which these models are created by the Voxel Editor, which has summarized before. So this is an internal tool to help the designers to create these characters. Yeah.
Mm-hmm. Yeah.
And this is Voxel tool. Yeah. It's another internal tool that I started. So it's helping the Voxel designers to create the Voxel textures, which includes the texture, the bump, metal, smoothness, and immersive effects. And it also integrated the game skybox and the lightings to make it as same as the game's looking. And it also contains a Voxel library management that can to name the Voxel and categorize it and export to a very large JSON file, which can be also imported to the game engine. Well, and don't mind the UI, I didn't spend too much time on it. Yeah, that's all.
Mm-hmm. Yeah, and then the service workers stuff. Do you want to talk about that a little bit as well? I know I just kind of threw these slides in there, but all right, I don't know if you.
First.
Yeah. So we also have support for service workers and offline editing in Box3 too, which are basically handled at like the root of the website. And the way the service workers interact with the rest of the API is we use MooRPC to basically write all the API types, and then the service worker can actually just intercept the API calls using the same schema that is used to serialize the messages back and forth to the server. And this allows for us to basically pick the subset of API calls that we need to sort of shim or re-implement locally so that we can buffer and implement the same like offline mode editing, right? So like you can modify like your profile or whatever, or like look at other content that you have cached locally on Box3, and it can do all of the searching in the service worker. So we have like a sort of parallel implementation of the API servers that we need in the service worker that can run on the client. And Yo-Yo put this stuff together too. So I wrote this slide, so that's kind of putting her on the spot to talk about it. So yeah, and then now I think with like maybe the next 5-10 minutes, I'll just say a little bit about like sort of the development and some of the higher level things that happened like sort of behind the scenes with Box3. So Box3 was a pretty cheap project, and like initially it was really just me and Yo-Yo and Timing working on this thing in the very early days. And then you know, we did kind of like ramp up to more people, but we were able to ship the first version in about 2.5 years from sort of start to finish on the project. And then, you know, sort of online for about another 1.5 years after that before my involvement was done with this thing. And it didn't cost that much to build this thing, right? Compared to like a typical project or MMO. It was really, really low cost. And I think part of it is because we did things in a very different way. We built it as a web project. We had a very tiny team. We were very focused on doing it. And we tried to lean very heavily on user-generated content. And probably the most controversial thing about Box3 was that it is a web game. And there, you know, is a lot of skepticism, especially in China, about investing on the web, right? Like there's not, you know, like out here, we sort of take it for granted that there is like the web, and that like obviously building things on the web is a good idea and should be like the default. But there's a lot of like almost hostility toward investing in web technology in China. Many people sort of prefer apps or APPs, right? That's sort of presumed to be like the thing that you should try to be building, right? But I still feel like even in China, there is a huge advantage to building on the web. And one of them is for sure, you get a better first-time user experience building on the web. It's a much smoother onboarding process. The games play instantly. There's no downloading, no installation. You have far greater trialability, which makes it much easier to pick and like get the first users in the door. Also, app stores in China, if you think like the 30% that Apple takes is bad, like it's common for many Chinese app stores to take like 70% cuts from the profits, right? Like it's extremely like nasty to work with them. And a lot of the Chinese businesses basically act as gatekeepers to try to like just keep apps or whatever from like launching. So by basically building on the web, we were able to bypass a lot of the really strict regulations for apps and just like a lot of the kind of gatekeeping and corruption, and just go directly to market and start selling it right away, right? And so that, you know, it was great just because there were like less rules around the web, right? And it was able for us to easily get that first traction and get those first users in. So that helped a lot. But the downside is that like just building anything at all on the web is significantly harder compared to building something on a native app, right? Like these days, a lot of game development has really standardized around Unity and Unreal. And like the trend, you know, has been going for like a while, but like Unity has a very strong position in terms of just developer mindshare. And it's very hard to like sort of find game developers that want to do anything on the web. Everyone's sort of fixated on building stuff in Unity and just, you know, sort of shipping things quickly. And well, Unity does have like the ability to compile for the web. Its multiplayer UX is extremely bad. And like the loading times and mobile support are just not really acceptable for something that would work, you know, really like in scale, right? Like you wouldn't want to do it too seriously at this point. Also, like one thing we kind of observed is that like even though we did deliver a PWA, users are not really trained to install PWAs, right? And I think this is kind of just a general pattern where maybe browser vendors can try to like improve this, or something could, you know, just kind of advance there. But like a lot of people just don't install PWAs, right? Like PWAs are there, but people haven't yet got the idea to like actually put them into your browser. And there's not an easy flow for like putting the PWA there. Most people don't get it, right? It just is, it's hard to push, it's hard to sell PWAs to users, right? And if you don't get it installed, you have to work a little harder and keep getting people to keep coming back to your platform day after day, right? And finally, and this is like a thing which I don't mind at all that we didn't have this problem, but it is one of the reasons why it can be harder to monetize on the web, which is that web apps don't have the same security problems that like native apps have, right? So you can't load them full of spyware and exploit your users to like make a quick buck, right? And that does sometimes make it harder to make cash with web apps, right? So that's one of the other things. And similar to this, I also want to do kind of a sort of reflection on building in China, right? So I think there are a lot of advantages to targeting China. I mean, the first is that it's a really huge market and it's relatively underserved. The quality of web services and apps and just the diversity of them is much more limited compared to what you get outside of the Great Firewall. So like a lot of stuff just doesn't work as well. You don't have to execute at the same level to basically reach market penetration. Like the standards are lower and there's a lot of people there, so it's much easier to get traction. And if you can break into it and get a lot of users, there's a very big potential upside. Also, development costs in China are relatively cheap compared to what they are overseas, right? So you can build things cheaper in China and there's a lot of upside. That sounds great. Why wouldn't you do it? Well, you probably shouldn't. And the fundamental reason that there isn't a lot of stuff in the Chinese market or a lot of competition is that it's a very hostile regulatory environment, and a lot of like potential platforms for marketing or getting users or even just monetizing require you to build and maintain local partnerships. So if you're a foreign company coming in, just forget it. You have really very few options for even just getting in the door. You're going to have to partner with Tencent and they're going to take like 90% of your profits or something like that, right? Like that's not good. And finally, even if you do make money in China, you'll probably run into the issue that RMBs are hard to spend. Like they're not easy to move domestic currency out of the Chinese market into the rest of the world. So, yeah, there's opportunities there, but there's a reason that no one's picking that fruit, right? It's probably not the best place to do it. And actually, we ended up getting kind of blindsided by this in a way because like sort of CodeMau's whole business was sort of regulated out of existence, right? And the government is really tightening down on all kinds of online games and education. So it's just not a good place to be right now, trying to do that stuff, just because the rules are just random and very capricious, so to speak, right? You can just get screwed for no reason. Like even if you do everything right, you'll still lose. So that's what it is. So lessons learned. I mean, you can build games on the web and even pretty good games like AAA games with high quality graphics and multiplayer. It's achievable. It'll probably be harder to do that than ship something with Unity and Unreal. It'll take more time to bring stuff up and get it online, but you can do it. Also, like building UGC requires good community management. And I didn't go into many details about it, but this is probably the most important thing for building and maintaining a UGC platform. China is also a great country. It's a wonderful place to visit. There's a lot of great people there. But also building stuff in China is extremely risky, especially for foreigners. Like just don't take things for granted. The rules there can just change, right? Like what you think is true today may not be true tomorrow. So that's that. So thanks for listening. So again, I will kind of wrap this up and bring it back to everyone. So we have Jinjin, Yo-Yo, Taiming, and myself, and then the rest of the team here who were not participating in this. But yeah, that's what we built. So good job, everyone. That's kind of my thoughts on this. I'll stop showing my screen now, and we can end the presentation. So there we go.
That's awesome. Thanks, guys. That was super awesome, actually. If you look at the comments on the chat while you guys were presenting, people's minds were repeatedly being blown, I think. I mean, at least for me, like the scope of the whole thing is so impressive. It's like you guys really built such a full-featured product. I mean, like even something like the MIDI editor that you demoed is like by itself is a full product for some companies. And and I know that like maybe some of the things you showed were internal tools only, but I mean a lot of it was public facing as well. So I guess like my first question, maybe this is me being like just not knowing that much about games, but like is that normal for a game? Do you usually build like so many different systems and different like like it's like 10 projects in one. It kind of felt like.
Well, yeah, you end up having so one of the first things, especially when you're doing a game engine, is bringing up your content pipeline, and that just becomes like that was actually a real like kind of blocker in the early stages, because basically when you're starting out with like a new game project like this, it's like, you know, it would be nice to throw more people at the team, but it's like you can't even do it yet because the engine tech is just too rough to be able to like add more people into it. So we had to do, you know, like all these kind of things to just make stuff work in the first place, where we could even start bringing data into this system and then rendering it and then doing all this other stuff. So I think like a lot of it is typical. This is also why games end up being like a lot of people. But most games will just do like really half-assed solutions for these things. Like they're not as polished as like what Jinjin created for, you know, doing these things, because they're not user-facing. But like the internal tools are like very jank, or like, and we had a lot of them too. There's even more horrible things going on behind the scenes you don't even need to know about, right?
Mm-hmm.
Yeah, I didn't even get into like all of the moderation systems we had to build too to run this stuff. And Yo-Yo built a lot of these things as well, right? She built a ton of internal tooling. And also she even did it without like any kind of like web framework. This is all just using like basic React and HTTP, like node.http for marshaling stuff back and forth, and like our own RPC stuff. So that's it. And the service worker stuff too. Yeah, it was a lot. And then Timing also was very instrumental in getting all these things like up and running too. He built like most of the horrible like, because, you know, like there's all these like great infrastructure as a service products that work in America. None of those exist in China. You're working with Aliyun, right? And I don't know, like Timing, what are your thoughts on Aliyun? Like, how would you describe Aliyun?
I don't like it.
That's very diplomatic. But yeah, like, yeah, Timing knows Aliyun very well now as a result of this. Yeah.
So like, how did you guys like decide what features to build? Was it like just ad hoc, or was there like some? I mean, I know this is a little bit less related to the code, but like, yeah, just it seems like, you know, you had to make decisions about like whether to build something yourself or whether to like pull it off the shelf. It seems like you frequently chose to build it yourself,
yeah,
which led to all this awesome stuff.
Yeah,
Yeah.
well, we were kind of forced to do that because most of the stuff that you could grab off the shelf just doesn't work in China, or it doesn't work on the web. So we had to basically do it all like completely like internally. Like it's all built. Yeah, like there's relatively few off the shelf things because there's nothing that worked for this problem that we're trying to solve.
Mm-hmm. Yeah, that makes sense. But I mean, what about in terms of the product itself? Like, what features did you talk to users, or was that just sort of like, did someone else kind of do that part, or how did you guys decide like what was worth building?
So in the early days, it was a little more ad hoc, and I think the project did kind of suffer some delays due to like lack of vision in the very like sort of beginning stages of it. But we were actually kind of lucky in that. And one of the things that really kind of kicked us into high gear, and unfortunately, like they're not here in this meeting, but we were able to actually hire one of the designers from Roblox to come work on our project. And he had a lot of very strong opinions about like the right way to do stuff. And that was good. And also we had a really great marketing community manager, and she did a lot of the work putting this together. So that would be Phoebe and Victor. So both of them, they're great. And like they did fantastic work doing a lot of like the design and figuring out like what order to do stuff and how to prioritize the features, and just interacting with all of like the users and the screaming kids and the like wannabe hackers and script kiddies and other problems that we had, you know, down there. But yeah, there's like, yeah, a lot of that stuff that went on to kind of make that happen. So.
There's a really good question here in the chat. Curious to hear stories of your favorite creative output or emergent behavior from users. Does anything spring to mind?
I don't know, Yo-Yo, what are some fun like games or stuff that you've seen kids make, or like what are some funny things? Or maybe Timing can talk about some of the kids who have hacked too. I don't know, like different stuff. Maybe Yo-Yo might have a good story or two.
They just like those how to say it, running games. They have to climb the mountain or some very dangerous place, and it's very challenging for the kids. So if one kid made this map, I think, yeah, and a lot of kids, they just like to challenge and over again to get the highest point.
Yeah, I don't know. They do these like weird parkour maps, right, where they try to climb up stuff or just glitch the game into like different modes or whatever. I don't know, that kind of stuff. Also, like we had a lot of issues with like account security too. We had one very aggressive user who kept trying to like impersonate other people and like steal their accounts and things, and this went on for a while. A lot of problems like that. So
that's really funny. I definitely did that kind of stuff as a kid. I understand. You know, when you're a kid and you're playing these kinds of games, I think sometimes the rules of the game itself become like an obstacle to overcome. You know, like the physics engine or just like even the social like rules around how the game is supposed to work.
The other thing that probably the worst thing that the kids do is they all try to break each other's maps, right? Like this is just like the most hilarious thing a 12-year-old can do is they trick another 12-year-old into giving up, because the maps are all multiplayer editable, right? And so you just convince the other person to let you play their game and be like, hey, I know how to do scripting or something. And then you get the scripting permissions, and then you just like mess up everything in their map, right? Like you turn them into a frog or something like that, or just blow up all the stuff. Right? It's really, really awful, the things the kids will do with that. So we have another feature I didn't talk about is we actually added a version control system that's very similar to Git, so you can roll back the games to any point in the editing history, which we needed to do to basically deal with this just mitigate this horrible behavior that these kids would have. So yeah.
That's really funny. I mean, that's part of learning and stuff. I totally I sympathize, because I was definitely one of those kids. I remember making I used to play this game called Gunbound, and I made a username that was like the name of the company that made the game, and they allowed me to register that username for some reason. And I was going around like trying to get people to like chat their passwords to me, but it would turn the system would like turn your password into stars if you typed it to a user to try to protect you. So, but you could tell people like type your password backwards, and I'll enable like extra super admin powers for you. And they would type their password backwards, and then you would be able to see it. Anyway, sorry, just reminiscing. But yeah, so one other question from the chat is, and I was wondering the same thing. Why did y'all decide to use IPFS? And like, what specifically was the benefit of that over some other kind of general blob store?
In the early days, we were trying to do more stuff with IPFS, but there were a lot of kind of performance issues with like some of the more fancy features for things like files and whatever. And then it just kind of went down to the very, it ended up being that we just ended up using the blob store for it, right? And the blob store is okay, it's acceptable. In retrospect, we could have done any kind of content addressable store, but like I know, like, people who worked at IPFS, I kind of like support the project. And I was just like, okay, like I'm willing to give this a good faith effort, try it out, see how far we can push it, what we can do with it. In the end, the content store, I think, held up okay, right? So that's really all we needed from it at the end of the day. The other stuff, like the weird, like the file tracking things and like a lot of the other things, it just didn't work well enough for us to really use it. So we had to kind of scrap that and then do it a simpler way, is what we ended up doing. But the content store is good enough.
So it sounds like you just ran an IPFS node or a set of nodes yourself, and you just pinned everything yourself, and it was just basically like a hosting, like an internal hosting. And so then did the clients also use an IPFS client to talk to the IPFS nodes, or did you just use something else?
No, they just pull resources from the web API using the multi-hash. That's it. So we just had a thing that was basically a gateway, and it would proxy or do a CDN for the multi-hash links, and that was it. So we kept the multi-hash naming scheme that sort of persisted through there. It was actually a good idea. I like multi-hash. I think it's a good format. We just didn't end up using like anything besides the content store from IPFS. So yeah,
that makes sense. And sorry, how did you actually expose the file information to the clients again? How did that work?
Everything is a hash. If you actually look at like.
But I mean, like, was it over HTTP or
just over HTTP? Yeah, we had Timing actually knows the gory details of this much better than anyone here, so he figured it out and put all that together. So you can ask him. I don't know. I'm just speaking for him because he does not like talking too much in English. So, but Timing, would you like to add anything?
Yeah, we just create a proxy to IPFS and export some endpoint, and browser can use this endpoint to get a file from IPFS. Yeah.
Mm-hmm.
It does HTTP. Yeah.
One question in the chat is which pieces of the project, which seems very modular, do you look forward to reusing in the future? And I mean, I guess implied by that is like kind of like what of the components are open source?
Probably the main significant open source component at this point is MooDB, which is sadly not well documented. And I just haven't gotten around to like writing up how all those pieces work. And I think there's a lot of good ideas from that could probably be like transplanted to other projects going forward. In terms of like other core stuff, a lot of that is proprietary right now, and I'm no longer working on this project. So I am not gonna try to like, you know, say what is usable or not from that or try to push any kind of open source agenda. So I think besides MooDB, I don't know, like there's really, like a lot of it is unfortunately kind of like sealed hermetically in this giant blob. It was also a huge mono repo, this whole project, right? And it was all TypeScript, like 100%, which was great because you could just do like find replace on like a field in an API and it would just propagate through the whole project and update it everywhere. It's like, so we had no integration problems when doing deployments, right? It was pretty cool. We had other problems going on. We could talk about that too, but there's a lot of, you know, stuff there. I think MooDB has some of the most interesting stuff, and maybe one day that will be kind of documented or talked about in the future. But
yeah, also I'll just shout out that you already gave a talk. You actually were one of the first. I think you were the first Speakeasy JS talk where you spoke about Mu schema relative.
Yeah, which is that's a very, very tiny part of the whole thing though. So it's just like one small thing.
Yeah, totally. And that was back when we were doing 2 different talks per Speakeasy event, so it was pretty short. But it is there on the website if you want to check it out if you're interested. Speakeasyjs.com.
Yeah. Also, I want to answer the question, like, how did this team come together? Which is basically CodeMao is a 6,000 person company. And for whatever ridiculous reason, they decided that I could be the chief scientist of this company, right? Which was hilarious, right? And so I ended up just picking up this group of misfits because no one else wanted to work with them. That was it. So yeah, we basically got kicked around by the corporate politics quite a bit. It was not the funnest place to work in some ways, but we survived it or whatever and came through, despite the meddling of HR and other problems. But that was pretty much it.
That's awesome. Well, yeah, I mean, it sounds like you guys all like came together, gelled, and like built something super awesome with this small team. It's really cool. Yeah, one question I want to follow up with, where I think Paul asked this, and I was wondering the same thing too. Yeah, voxels. Like, were you glad that you went with that approach? Would you do that again if you were building a new game? What do you think about that?
I mean, I feel like it's mostly just mesh stuff. I think voxels are great, and I think for kind of like the performance spec we were trying to target, trying to do something else would have just been like probably not possible for us to like actually ship. Like it wouldn't have worked on like mobile or whatever. We couldn't have done that. So I think it worked pretty good. I don't feel like it was the hardest part of the project by any means. In fact, like the core voxel stuff came together very fast. I would say that was done like under a month, where most of the time was invested was sort of building out the platform and like the network and multiplayer code, like those things, and like also just adding features to the script API. Like that stuff just spirals out into a very large project, right? But the voxel stuff wasn't that bad, no. And I think if I were to do it again, just looking at where technology is going today, I would probably, I think timing just vanished, but I would probably go more toward something like kitbashing, like especially if you're targeting like next gen stuff, right? It sort of depends what you want to do. But I think probably the future of a lot of content creation, like just looking at stuff like Nanite that Unreal is doing, is just going to be kitbashing like massive chunks of polygons together. So I think it's probably going to be polygons in the future and probably just like massive kitbashing stuff. Just like, because it turns out like for a while, people were like, I guess you just can't render 10 million or like infinite polygons, right? But then like Unreal just came along and did it. And now, like, I think after that, you got to really rethink how you do a lot of stuff, right? So I think just massive kit bashing would probably be what I would do in the future. Just like prefab objects, stack them on top of each other, infinite number of prefabs. That's it. But voxels are good for low spec, right? Because they're cheap. It was really not that much to do this with all like the lighting and everything. So it worked for us. I think going back in time at that moment, it was still probably the right call. I'm not as sure it would be the right call to do it today, but I feel like in 2016 when we started it, it was the right play. Or 2017 when we started this, yeah.
Yeah, all right, maybe this is our last question. Do you think that targeting the web made running user-created worlds easier or harder versus an engine like Unity?
Definitely harder. I mean, well, but that said, though, there is a sort of poison pill, right? Because if you are building a UGC game like this, you should expect that if you get big enough, Unity is going to be your competitor, right? Like flat out, they're not your friend. And like if you as a developer make a UGC platform, you're going to be like basically exposing and re-implementing all of the APIs and stuff in Unity. So you shouldn't trust them as a platform for building a project like this, which is why like Roblox, for example, has their own engine, right? Like Unity is not your buddy. They're going to get into the metaverse space one way or the other. So I wouldn't, you know, I mean, Unity could build that, right? And if you built it, you might think that you're trying to, you know, basically like do your own thing, but Unity will just eat you like later, or they'll just come over and do the whole thing that you're doing themselves and you'll be out of a job. So yeah. So I just, Unity isn't really an option just because like from a business standpoint, it'd be a terrible idea.
Yeah, I'm glad that you went with the web approach. I've always felt like, even though it's more work, you know, and there's all the browser incompatibilities and all the other stuff you mentioned about, you know, getting a game to work on the web, especially on like low performance, you know, crappy performance devices. The benefits seem so good to me for like a game, you know, better first time user experience, like smoother onboarding and no installation, and like even just being able to send a link to your friends to join you in the world that you're in, and you know have them like you know be able to just teleport like right next to you. You can just blast out a little link to everybody and say, hey, come play with me, or check out this crazy thing that's happening right now. I'm just surprised that we haven't seen it more. Because it's just it seems so powerful. Like, you know, I could be like playing a game and then send a link out on Twitter and say, hey everybody, like check this out and come join me. And yeah, and then I mean, and on top of that too, like in the US, I know that a lot of kids often want to play web games over like installed games because you can't install software on school computers, but you can use a web browser, so you can just navigate. Yeah, so I'm just surprised this is not more. Why have we like? I mean, do you think there's something else? Like, why haven't we seen more of this?
The short answer is it's really, 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 really hard to build a game on the web. That's really what it comes down to. It's not like a mindset or anything. It's just the tools aren't there. Like it's frustrating to do it. And also like, you know, JavaScript is just a hard language to write a game engine in. It's not like the best platform for doing this stuff. So that's it. It's hard. I think that's really what it comes down to. I think Jinjin got kicked out of the shopping mall he was hiding in.
Cool. Well, we're about out of time anyway.
Yeah. Also, I think Jinjin and everyone, I don't know if you're like looking for work too, but these guys, they're all fantastic, right? They're worth far, far, far more money than CodeMao was paying them. So like if you guys are looking for really cool web developers, any of these three or whatever, really good people. So I don't know. I don't want to like destroy... I don't want to like burn too many bridges, but at the same time, I feel like they've already kind of burned the bridges a bit.
So I'll put the names up on the screen if anyone wants to, you know, reach out about work. It's up there. And yeah, do you guys have anything else you want to say before we go to the social event? Nope. No final thoughts. Okay.
Okay.
Cool. Well, thanks again. This is like a whirlwind talk. Like I know that you just had barely enough time to touch the surface of all these different things, but like you can really get a sense for the like scale and like the complexity of what you guys have built. And like And the fact that it all comes together in like a game that like is actually fun for kids to play and it was, actually successful is even cooler. So just thanks for giving us a peek inside and for sharing it with us and for staying up until 1 a.m. to do it. Super appreciate it.
Yeah, they all did fantastic work. So yeah, and also I also want to say like a shout out to Phoebe Wang and Victor, who were also really awesome on this project too. Maybe like, I don't know, can put their info up there. And there are a lot of people on the team. Like a lot of people worked on this stuff too. So.
Yeah, and if you want to find their GitHub profiles, they're linked from speakeasyjs.com. Next to the talk title, you can just see the usernames. You can click on them, and that works.
Okay.